Without using mathematical table or a calculator, evaluate 5.4 over 0.025 by 3.6. So in this question, we first of all express the decimals as fractions. So on the numerator we have 54 over 10, and then on the denominator we will have 25 over 1,000 times 36 over 10. So this simplifies to 54 over 10 divided by 25 times 36 over 10,000. So we can also express this as 54 over 10 times the reciprocal of the second part, which is 10,000 over 25 by 36. So here 10 goes into 10,000 1,000 times. So we will have 54 all over 10, or rather all over, so that is 54 over 1. Well, you can have it as 54. We can have on the numerator 54 by 10,000, 1,000 over 25 by 36. So at this particular point, we will factorize each and every number, like 54 factorized becomes 2 in power form, that is 2 times 3 cubed times 10 cubed all over 25 factorized, we get 5 squared, and for 36 we have 2 squared by 3 squared. Still on 10 cubed we can have 2 by 5, so we have the next 2 by 3 cubed by brackets 2 by 5, which is 10, and that is raised to power 3 all over 5 squared times 2 squared times 3 squared. So in the numerator we can open the brackets as follows. So we have 2 by 3 cubed by 2 power 3. Remember here we have 2 power 1, 5 power 1, so 3 multiplies by the power, so we have 2 power 3 times 5 power 3. 5 power 3 there, and then you also have on the denominator. Now let's arrange them in the order, ascending order. So we begin from 2 squared times 3 squared times 5 squared. Combining 2 cubed and 2 power 1 here, we will have 2 power 4. Then multiply by 3 power 3 times 5 power 3. On the denominator we'll have 2 squared times 3 squared times 5 squared. So applying the laws of indices, we know that if you have a power n divided by a power m, the result automatically has to be a power n minus m. So that is the law that will apply, so that 2 power 4 divided by 2 power 2 will give us 2 power 4 minus 2, that is 2 power 2. And then for 3 power 3 divided by 3 power 2, that should give us 3 power 1, that is 3 minus 2. And then finally 5 power 3 divided by 5 power 2. So we have 3 minus 2, which is 1. So we have 5 power 1. So that is our result, which will simplify further to 4 by 3 by 5, that is 60. So there's all the evidence that we've not used mathematical table or a calculator. So this secret here is simplify by factorization, and where possible cancel. So that's it for this number. So in this number we are to express 1728 and 2025 in terms of their prime factors, hence evaluate. Now first of all, you can use the factor tree to express 1728 as a product of its prime factor, so that 1728 being given as 2 power 6 times 3 power 3. So for 2025 we will have 3 power 4 by 5 squared. Now on the numerator we have cube root of 1728, which can also be expressed as 1728 raised to power third. And that means for the numerator we will have 1728 is 2 power 6 by 3 power 3 raised to a third. So here we are going to apply the law of indices, which states that if you have the number a raised to m and then it's raised further to n, the result is a raised to the product of m and n. So we'll apply that here. So we are going to have next 2 power 6 raised to a third times 3 power 3 raised to a third, and applying the law down there we will have 2 power, now we have 6 by a third, that is 2 times 3 power 3 by a third, that is 3 power 1. So we're done in the numerator. On the denominator we have the square root of 2025, which can also be expressed as 2025 raised to power a half. So substituting the factorized form, so we will have 3 power 4 times 5 power 2 raised to power a half. Again, applying the law down there, the laws of indices, we will have this simplifying to 3 power 4 raised to a half times 5 power 2 raised to a half. So that gives us 3 power 2, because 4 by a half is 2, times 5 power 1. 2 times a half is 1. So that gives us the denominator. So finally, to evaluate fully, we have the numerator. So that implies that the numerator, which we already got as 2 power 2 by 3 power 1, will be divided by the denominator, which is 3 power 2 by 5 power 1. So here, applying again the laws of indices, we will have 2 power 2 all over 3 power 1 divided by 3 power 2. So we'll have something like, there we'll have 3 power 1 divided by 3 power 2. So we subtract according to the laws of indices. We have 3 power 1 minus 2, that is negative 1. So we have 2 power 2 times 3 power negative 1. So we have on the numerator times 3 power negative 1. And then on the denominator we have 5 power 1. So this should give us 4 over 3 by 5, which is 4 over 15. So finally, that is the result. So essentially, we've just factorized the numerator, factorized the denominator, and then applied the laws of indices on them to simplify. And finally, we've arrived at that result. In this question, Juma left his home at 8:30 a.m. He drove a distance of 140 kilometers and arrived at his aunt's home at 10:15 a.m. Determine the average speed in kilometers per hour for Juma's journey. Now, the average speed should be given as the total distance all over the total time taken. But the total distance covered, we already know, is 140 kilometers. But the time interval between Juma's home and the aunt's home during the journey is from 8:30 to 10:15 a.m. So the difference would be, if you have 10:15 a.m. minus 8:30 a.m. So that's a difference of 1 hour 45 minutes. 1 hour 45 minutes should be 1 3/4 hours. It's better expressed as an improper fraction, and that should be 7/4 hours. That way, when you use it in the next procedure, it becomes simpler. So finally, we have the total distance and the total time taken. So the average speed would then be calculated as the total distance, which is 140 kilometers, divided by the total time taken, 7/4 hours. So that is 140 by 4/7. That should give us 80 kilometers per hour. So that's it for that number. So in number 4 we are to expand and simplify. 4 into q plus 6 plus 7 into q minus 3. Expanding simply means removing the brackets, so we have to multiply 4 by the terms inside the brackets. So we have 4 by q, that is 4q, plus 4 by 6, that is 24, plus 7 by q, that is 7q, then 7 by 3, that should give us 7 by negative 3, that is minus 21. Now collecting the like terms, we have 4q and 7q adding up to get 11q, plus 24 minus 21, that should give us 3. So at this particular point it's already in its simplest form, we cannot proceed further. So that is the result for number 4. So in this question, in the trapezium PQRS shown below, PQ is 8 centimeters and SR is 5 centimeters. Sorry, it should be 6 centimeters. So this is 6. So 6 centimeters. So that if the area of the trapezium is 28 square centimeters, then we should find the perpendicular distance between PQ and SR. That is the distance, if you drop a perpendicular distance from point S to line PQ so that it meets it at 90, then we are looking for H, that height. So given that it's a trapezium, we'll use the formula for the area of a trapezium, which is a half times the height into the sum of two parallel sides, so which in this case we have 6 and 8. So that should give us 28 square centimeters already provided in the question. So this will simplify to 14 over 2h is equal to 28. So in order to find h will be, that is 28 over 7, because this should give us 7h. So dividing both sides by 7, we have h as 28 over 7, and finally that gives us 4 centimeters. So that's it for that number. So given that cube root of 9 power 4 is 3 power n, find the value of n. So in this number, if we consider the left hand side, we will have 9 power 4, and the cube root of that can also be written as 9 power 4 raised to power a third, so that we have, when we apply the law of indices that states a power m raised to n should give us a power m times n. So applying that to the right hand side of that equation, we are going to have 9 power 4 by a third, that is 4 over 3. So that is still equivalent to cube root of 9 power 4. So next we factorize 9, and 9 factorized will simply give us 3 squared. So 3 squared is raised to power 4 over 3. So we have power 4 over 3. Still on this law of indices, we'll have that giving us 3 power 2 by 4 over 3, that is 8 over 3. And then that was the left hand side. Now equating the left hand side to the right hand side, we are going to have 3 power 8 over 3 equated to 3 power n. So because the bases are the same, we have 3 and 3, we can comfortably say that 8 over 3 is n, and therefore that would mean n is 2 and 2/3. So 3 villages A, B and C are such that B is 53 kilometers on a bearing of 295 degrees from A, and C is 75 kilometers east of B. And then using a scale of 1 centimeter to represent 10 kilometers, draw a diagram to show the relative positions of A, B and C. So here we want to locate B from A. So we are told that B is 53 kilometers on a bearing of 295 degrees from A. So if we are positioned at A, so we'll have to draw a true northing at point A. And then you're told to locate B from A. B is on a bearing of 295 from A, so we have 295 right there. So that is 295 degrees measured clockwise from the true northing, and that will take us to point B. So let's have point B right there. So this is a sketch. We are beginning with a sketch. So B, we've been told, is 53 kilometers away from A. So this point is point A. And again, we are told that C is 75 kilometers east of B. So if you are at B, then C is located 75 kilometers east. So east is directly in that direction, and the distance is 75 kilometers up to point C. So C is located at that point. So using a scale of 1 centimeter to represent 10 kilometers, draw a diagram to show the relative positions of A, B and C. So we are going to draw a scale drawing, and for the scale drawing we are instructed to use 1 centimeter representing 10 kilometers as the scale. So that means for the distances AB will be 5.3 centimeters, then BC will be 7.5 centimeters. So we will be copying the sketch But to ensure that our values are accurate, the readings that we get from our scale drawing, we will have to ensure that the true northings are all parallel. We must indicate N for north at that particular point. So this line, that line, and that line right there all have to be parallel for the sake of accuracy. So upon drawing with these measurements, then we expect for part B the measurement of CA to be 3.5 centimeters. But remember, we have to leave our answer in kilometers, so converting with our scale, 1 centimeter represents 10 kilometers. Therefore 3.5 centimeters should give us 3.5 by 10, that is 35 kilometers. So remember, in an exam situation, because it's a construction and prone to little errors, we can have an allowance of 0.1 centimeters. So that's it for that number. So in this number, a retailer bought a bag of tea leaves. If the retailer were to repack the tea leaves into smaller packets of either 40 grams, 250 grams, or 350 grams, determine the least mass in grams. If the leaves of the tea leaves, determine the least mass in grams of the tea leaves in the bag. So here we are required to get the LCM, the least mass, and that is the LCM. So in order to get the LCM of 40, 250, and 360, then we can express the numbers as a product of their prime factors. So we had 40 being 2 cubed by 5, and 250 will be 2 by 5 cubed. We also have 350 grams, so that should give us 2 cubed by 5 cubed by 7. So in order to get the LCM, so in this number, a retailer bought a bag of tea leaves. If the retailer were to repack the tea leaves into smaller packets of either 40 grams, 250 grams, or 350 grams, determine the least mass in grams of the tea leaves in the bag. Now here we are required to get the LCM, which will represent the least mass in grams. So for us to get the LCM of 40, 250, and 350, so we can express them as products of their prime factors. So if you use factor tree, you'll get for 40, 2 power 3 by 5. For 250, we will have 2 by 5 cubed. And finally for 350, we will have 2 by 5 squared by 7. So in order to get the LCM, we will have to go by all the factors that appear in all these expressions. For example, we have got 2 appears here, we have got 5, we have got 7, but we will have to consider ones with the highest powers. So for 2, with the highest power, that will be 2 power 3. And for 5, the highest power will have 5 power 3. And for 7, we only have 7 power 1. So that so far is the highest power. So finally, that gives us the LCM, of which we can also express as this is 8 by 125 by 7. So that should give us 7,000 grams. So that's it for that number.